All right, everybody. Welcome to Tech Talks. Sorry, office hours. Can you hear me all right, Nathan?
Can hear you all good.
All right. We'll let another minute or so go by. Let everybody join. Looks like we got a pretty good turnout today. So I'll introduce myself, and Nathan, you can introduce yourself, and then we'll talk a little bit about what we're going to be doing today and the goals of our office hours here. So I'm Jesse, head of TCD engineering at Telos, and one of the original members of the Telos launch group. So I've been around since very early days of Telos and built a lot of fun, exciting things that we have on Telos, our EVM, a bunch of other stuff. So really excited to have anybody here who's interested in what we've built or interested in building some of their own things on Telos. Just put a question in the chat. We can give you permission to speak if you want to talk or anything. We're really here to help you out. Joined by Nathan. Nathan, you can introduce yourself.
Yeah, what's up, everyone? My name is Nathan. I'm the technical onboarding specialist. So really just helping developers and anyone interested in building on Telos, just do that, make that an easy journey, support them through anything that they need. And yeah, really happy to be here and happy to, kind of ease that transition into developing on Solidity if this is someone's first time, or, if you're somewhat comfortable but just want a bit more experience. I mean, Jesse is the go-to guy. So very, very great opportunity to have very rich learning experience. So yeah, happy with everyone and happy to also learn from Jesse today.
Yeah, so office hours is, some people might be familiar with. It's kind of an in-person traditional software or regular any company, just kind of like an hour once a week that leadership or in my experience, some of the architects of the software that the company runs will just offer an hour, a couple hours a week where anybody can just stop by their office and ask questions. So it's kind of like the open door policy opportunity for anybody to come in, or as we've now moved remote for a lot of business, they'll set up a Zoom call. Anybody can join and just come ask your questions, bring your ideas, bring your questions. It's really an opportunity to engage directly and learn or share thoughts or get unstuck if you're stuck on a problem, things like that. So that's the goal here at the TCD office hours, trying to give developers building on Telos an opportunity to ask questions, learn about how to do certain things. We can show examples, just anything that will benefit people building on Telos. That's what this is for. Of course, we don't expect people to just come and keep us busy with questions, so we also have a loose agenda for what we're going to do. And for today, we're going to be doing a simple token launch. We saw some people talking about how to launch a meme coin. I don't necessarily want to encourage and perpetuate, a huge amount of meme coins on Telos, but just a traditional ERC20 token, how to launch it, and kind of some of the process there and the concepts. We can go through them, and we'll do it live so people can see how it works. This will all be recorded so that people can watch it later, follow along themselves.
Yeah, I really encourage, as we're going along, if you understand something or want some clarification, put it in the chat. I can voice it if you want to speak as well. So yeah, I want to make it as interactive and beneficial for y'all as possible.
So I am going to start by sharing my screen because I'm going to be the driver here. And hesitate to share my widescreen. So I'm going to start by sharing animation. And There we go. So what is the first step to building on Telos? Well, start on the testnet. So what you see here is my browser. We're going to do this first through Metamask and Remix. We're going to use the OpenZeppelin contract wizard and deploy a token contract that's built by the OpenZeppelin contract wizard. And we're going to deploy it to the testnet, and then we're going to go interact with it, go see it on the Explorer, and then we will use a UI. We have a UI template that anybody can use to get started, and we'll use it in that UI to kind of demonstrate the whole process. So a first step would be to install Metamask, which is your wallet here. You can see here I have an address that's already generated, and I've already got Telos Testnet load balancer in my list of networks.
Hey, we aren't able to see your MetaMask.
Oh, yeah. So let me try and fix that. I will open it up. You can't see it, but if you install Metamask, it's a browser plugin, so you don't see it when I click it. But the three dots in the top right take you to the menu, and if you click Expand View, it'll open up Metamask in its own tab, which sometimes is easier because Metamask's UI is pretty cramped sometimes. So this is a little bit easier to work with anyway. So you can see here, I've got my mainnet number 2. You can name them, right? So I have dev only, right? This is my dev only address. And I'm connected to the Telos Testnet load balancer, which is the RPC endpoint that your wallet talks to. One way to add the networks, there's a couple ways to add Telos to MetaMask. One would be chainlist. There's a few of them, chainlist.org, chainlist.xyz, I think chainlist.wtf might even work. But you'd come in here and you type Telos, and you get Telos mainnet. So if you needed to add the mainnet, there it is. Check the include testnet box. You'll see the testnet, and then you can add it to MetaMask. Now, it's already been added to MetaMask, so I'm not going to add a duplicate. I think because the name's not the same, it might want to add a second one. But that's how you can add Telos testnet or mainnet to MetaMask. Another way is just through our explorers. So we have Teloscan.io as our block explorer there. You can also go to the testnet explorer, and that's testnet.teloscan.io. And when you click connect wallet, it will, so if I sign out, when you click sign in, if you don't already have the network added, it will prompt you. So just a few different ways to get the network configured in MetaMask. You can, of course, click these three dots, go to settings and networks, and you can also manually add the network, pasting in the information you need there. Just the other ways are more friendly. They do it for you. So that is the first step to working with any EVM really, is to get a wallet, MetaMask being the most popular one, set up. And then the second step to deploying a contract is, you need some tokens to pay for the gas price. So to get the tokens to deploy a contract, the tokens to test with on testnet, you would come to MetaMask here. You would generate, you can make more addresses if you want. You can add accounts. You can add all the keys you want through MetaMask. I already have this one created, and I'm going to click this little icon here to copy that address ending in 08A5. And I'm going to come to our faucet. We have a testnet faucet here, and the URL app.telos.net/testnet/developers. And we'll get these links all pasted into the chat and into, I think once we get it up on YouTube, we can put it maybe in the comments. But this is where you come to get tokens on our testnet. Now we do have our native network, which requires you to have an account already created. So we have a process if you're building on native, enter an account name and the public keys to use. It'll create the account on Testnet. If you already have the account on Testnet, you can just paste the name of the account here and get some Testnet tokens. Or if you want EVM, that bottom one is the way to go. I paste the address there ending in 08A5, and I say, send me some tokens. And then we can come back over here, and it should refresh pretty quickly. I got 50. So now I have 50 tokens to work with on the testnet, and I'm ready to go to the next step. Now that I've hit the faucet for some funds, I'll close that tab. And this is the OpenZeppelin contracts wizard. So if I refresh this, it'll start with an empty ERC20. So to touch on OpenZeppelin, what is OpenZeppelin? OpenZeppelin is a project that builds the smart contracts, the reference smart contracts for EVMs, for Ethereum and any other EVM. So ERC, you see ERC20, ERC 721, 1155. Those are the three that they have here in the wizard. ERC stands for Ethereum Request for Comments. So in software development, that's a process that engineers will use to iterate on an idea. So you post a request for comments to like the RFC system, right? RFC number, whatever, the number of your RFC. So you get a new number when you post a new request for comments, and you're asking people to comment on your idea. And then people go back and forth. The idea gets kind of shaped through collaborative discussion, and in the end, through some kind of oversight body. I'm not sure exactly how it works on Ethereum with ERCs, but it's established. It's ratified into like a standard that everybody agrees that they'll use. So ERC20 is the token standard that is used across the board on EVMs. ERC 721 is the non-fungible token standard. So the NFT standard is 721, and then 1155 is the semi-fungible ERC standard. So these are just different specs that define exactly how the contract should behave, what the name of the functions are, all of the things about the contract. But the standard doesn't provide you with the actual code. It provides you with how the code should behave. And what OpenZeppelin has here for us is the actual implementations of that code. They've built implementations, they've audited them, they're hardened, they're trustworthy, they're reliable. And they've taken those standards, as you can see here. Not only have they built them, but they've made this wizard that's really nice. So you could go to their GitHub and figure it all out and copy paste it. There's a bunch of ways to use what OpenZeppelin has built, but this wizard is super friendly. As you can see, you can switch, you can get different options depending on which type of contract you want to build. You can go custom and start adding certain things. In this case, we're just going to do a normal token. You can edit things in here. You can also add features. So for this one, I will say if you don't do anything here, it's going to deploy a token that you can't mint. So if you want to be able to mint more tokens as time goes on, you need to add mintable. And it does it for you. You click the button, boom, it adds the function. It adds the, it imports some other contracts, and now you have the mint function. You can mint to an address this amount. Then you might want it to be burnable, so you can burn things and mint them. And you might want it to be pausable, because maybe you need to pause and kind of freeze the contract for who knows what purpose. There's all these other options. So we'll just call it there. This is now already built out for us, and we can look through kind of what some of these concepts are. Now, I could copy this to the clipboard. I could copy it myself, or I could open it in Remix, which is slick. click the button, and it opens that exact code in Remix. So what is Remix? Remix is it's a website. It's a web-based IDE. An IDE is a integrated developer environment. It's the piece of software that you use to build other software. And Remix is an web-based IDE that it'll help you build the code. It'll compile the code for you. It will deploy the code to a network, and it will publish the code, verify the code for you, so that people can see the source code and interact with it. So before you go too far, if you're doing this yourself, I would encourage you to install the Sourcify contract verification plugin. So you can come down here to this little icon, the plugin manager. You can search for and find the Sourcify contract verification, and you can install it, because that's kind of the last step of deploying. And on Telos, we use Sourcify, which is a third-party decentralized contract verification tool. They do a really great job. So here, let's see, we're on this. So these are a list of your files. If you build more things, they end up accumulating here. Sourcify has some really cool cool plugins you can look at here. It interacts with GitHub. You can actually install something on your machine where you can synchronize a folder from your computer into the browser, so you can actually be editing files that are already on your machine and not just editing files in a website. So there's a bunch of really cool stuff that Remix has. In this case, it has basically pasted this code from this wizard, same code. It's done it all for me. So what are some things that we would want to change here? It's created a token named MyToken with the symbol of MTK. So any ideas of something better than MyToken? Drop them in the chat if you have any suggestions or, fun ideas for the symbol, which is normally all caps and maybe, 3, 4, 5, 6 characters. I don't know the max. I think it can go a little bit bigger, but you don't want it to be, too big. And then the name, which can be bigger, like what is it? Shiba Inu, Sonic Boom 10, whatever. There's some pretty wild ones out there. So you need to give it a name, because once you deploy this contract, you can't change it. So you can't really change the name. That's set when you deploy it in the constructor, and that's it. All the other code you can see here, pretty simple. The reason you don't see a lot of code here is because what it's doing is importing the actual ERC20 implementation. It's importing these 4 other files where you would see a lot more code actually implementing things. And then here, all you see on your token contract are the functions that are relevant. So mint, pause, unpause, and the owner concept. So it's going to make the contract which deployed it. I'm sorry, the address that deployed it. Remember my address that I had here in Metamask, this 08A5 address. That will become the owner of this contract. And if you noticed here, this does a lot of stuff without even telling you why. But if you look here, when I add mintable, it also checks the ownable box, because who's allowed to mint it? Well, if you're going to have a contract, a token be mintable, you have to have an owner that is like the authority that has permission to mint. So now that owner becomes the person the address that deployed the contract, and the owner is the only account that can do the minting. So you see, when you make it an ownable contract, you now get this modifier called only owner, and that modifier there basically will ensure that this function can only be called by whoever the owner is. So these are kind of when you see only owner, when not paused, things like that, right? So when not paused, it's pretty straightforward. It's a modifier that will make sure that this token, this function, which is before token transfer, self-explanatory. It's a function that runs before a token transfer. This function can only happen, it will fail if it's paused. This function can only run when not paused. So it's really, self-explanatory when you look at it, but it's very hard to understand until you're familiar. So this contract here is ready to go if we just give it a name. Fast.
Yeah, Sir Fizzbun said fast.
Let's call it fast. So FAST for the symbol, and then the name can be like really fast. Huh? There we go. So that gives us a contract that will deploy. In this case, it's going to deploy with 0 supply, but it is mintable. So we can mint it ourselves when it's deployed. So here we go. Let's see. Time's good. You want to go to the compiler first, compile the contract. Now, every time you make a change, you'll see here. So if I call it fastz, watch this icon here. It just kind of flashes. It recompiles it. Every time you change anything on the contract, it recompiles it. So we've already compiled it because it's green, but I'll click it again. I like to be sure. Now we know we've compiled this contract. And we would like to deploy it. So it's kind of a sequence here. You have your file explorer where you explore your files. You can search your files. You can compile your files. And then you can deploy what you've compiled and run transactions. So the first thing here in the deploy panel is the environment. So where do you want to deploy it? So Remix VM. Remix is great. It literally can run a Ethereum virtual machine, an EVM, with any of the known hard forks of EVM right here in the browser. So it can actually run and simulate your contract running in a VM that's right here in the browser. You can connect to Wallet Connect, which is one of the kind of protocols for for wallet interaction. There's just a lot of options here for which environment do you want to deploy to. I'm going to pick custom external HTTP. Oh, I'm sorry. I'm going to pick injected provider, Metamask, the first one. You pick injected provider, Metamask. It's now going to talk to Metamask. It's going to deploy using this address and these funds to that network. So 08A5 will make sure is the one that's doing the deployment, and it's going to deploy to that network, the Telos testnet. So it's going to deploy. Oh, it's got the wrong. So I guess maybe it's going to use a different account that I have here. I think I would need to log out if I wanted to. Here, I'm not sure how to tell Remix to pick a new account.
You can disconnect it. There should be a.
Oh, disconnect. Do you know?
I try to reconnect with the other account pulled up.
Yeah, see if I reload, I'm going to lose my code here. Well, I can also just use the account, one of the accounts that's in there. It's a problem you have when you have too many accounts. Home, is there a logout button? Come on, Remix, what do you have for me? Well, let's just go forward with one of these other accounts, it's fine. Injected provider Metamask, account. Okay, so we'll just pick I just want to make sure I know which account it is. Here's one ending in 01CD, and we'll go to this one, test only. There we go. Look, I've used it on Remix before. Through this browser, it remembers everything I've done. So 01CD has about 50 tokens, obviously from the faucet. So we're pretty aligned with what we'd already done. So 01CD, I just like to double check everything a few times. 01CD, we're good there. So we're going to deploy this contract here, named really fast with the symbol of fast, to the custom network with a chain ID of 41, which is our testnet. We're going to deploy through Metamask using that account, that contract, so it knows the name. Well, it thinks its name is my token still, but D43, this is the same file, and we're going to click deploy. It's going to pop up Metamask. You're not seeing it, but I have a pop-up here from Metamask asking if I approve deployment, telling me how much gas I'm going to spend to deploy. I'm going to confirm that. And it's deploying. Boom, it's deployed here already. You can see the information. If we look at it down here, it has all the information about the deployment. And one concept that's important is that when you deploy a contract, it will generate a new address for you. That's where the contract will be. So the address that I used to deploy that had the tokens from the faucet is not the address that the contract will be on. I could deploy hundreds of contracts with that address. Each contract will get a new address called the contract address. You'll see here I can copy it. You can see here B2C8 is the address, the ending of it. Here that it now has the contract deployed at B2C8, and you can see all of the functions that are available to call. These down here in blue are read-only functions. So if I click symbol, it tells me the response for calling the symbol function is fast. Total supply should be 0. Paused. False. It's not paused. Who's the owner? 01CD, the address that deployed it. What's the name? Really fast. All right. Decimals should be 18 because that's the default number of decimals on a token contract. So you can see those are all read functions, and you don't need to sign any transactions to do a read function. But if we wanted to mint, we need to figure out how much to mint and what address to mint to. So if you look here, what address do you want to mint it to and what amount? So let's mint to ourselves in this case. Let's just mint to ourselves. And let's mint. Now this can be a little tricky because in this case, it's asking me for a uint 256. So a uint 256 is a unsigned, meaning it's not a negative or a positive, it's just a number. It's always a whole positive number without a sign. Sign would be the plus or minus. Number, integer, 256 is the number of the size of it, 256-bit integer, which is a pretty big integer. You can get a big number in there. And it's without decimals. So it's not a floating point number. It's not a decimal. It is a whole number. So there's 18 decimals. And in any smart contract, any blockchain, they're not going to traditionally be using decimals. So or any floating number, there's not going to be a decimal number. So in the contract, it's always dealing with a whole number. So if I put in 1, that's actually, from a human's perspective, not one fast token. It's one unit of it with 18 decimals. So 0.17 zeros 1. That's what 1 is. So if you want a bigger number, you can just add zeros. You can also go to ethconverter.com here. Way is 18 decimals. Ether is, so if you go like that, you can see 1 ether is that many way. So if we wanted to transfer, let's say, if we want to mint 5 of these tokens, we actually need to enter that amount to get that properly done. So that's a lot of zeros. We're going to transact here. We're going to mint and confirm. And now we have another transaction, a mint. So how can we see that? Well, first let's go to the Block Explorer. Well, first let's copy this contract address. Now let's go to Teloscan, Testnet, and let's look at it. Well, there you go. You can see a few seconds ago, a mint happened from this address. And the ERC20 transfers, if we look at this transaction right here, 5 fast, you see 5.0 fast, right? So we got our decimals correct, right? We didn't just send 0.00005 fast, we sent 5. Minted means it was a transaction transfer from the 0 address to the address that we said to send it to. And this is the address that received it. And you can see that token transfer here. And we've already picked up the name of the token is really fast. So you'll also notice it's not verified. So we talked about verification. So let's go back here and go to the Sourcify plugin. We will go to Telos Testnet. So we're going to, that's to look it up. We want to verify it. So Sourcify also will let you import a contract that's already been verified. But in this case, we want to verify the contract. So Telos Testnet. And the contract name will be my token. Even though it's not my token, Remix thinks it's named my token because that's what it was named when we imported it. And it needs a contract address. So we'll come over here, we'll copy that contract address. So what we're doing here is we're saying, we're asking Remix to take all of the information about this contract and when we deployed it, send it, upload all the source code and all of the information to Sourcify, and we want to verify it at that address because that's the address that it's been put at. So we'll see here. Sometimes, well, working great today. Sometimes it's a little slow. You just retry. Now, one thing to highlight here is it doesn't immediately show up on Teloscan. So if we look here at the contract tab, you'll notice there's no functions, but it does have a few options. So let's talk for a second about what an ABI is. So an ABI is a application binary interface. Kind of sounds like API, which is an application programming interface. And API talks about doing like REST calls or interacting, just reading data through an API. That's probably things that a developer might be more familiar with. A ABI is how you interact with binary. So it talks about how you encode and decode like the human readable data, like the mint address and amount, and you send the data encoded. You turn it into like binary, like bytes, so that this contract that's deployed can receive your contract call. So if you want to mint, the ABI says there's a function named mint, and you send an address and a uint 256 to mint it, and the ABI tells the code how to compile it into bytes from the human readable address and semi-human readable amount. And it's a big number, right? So now we have this ABI. Where is it? Well, if you come back to the file browser and you go to your artifacts, you can find all the contracts that you've ever compiled and deployed. So I'm looking to find the artifacts for contract-45BC, which will be somewhere right here, contract 45BC. That's the contract I need the deployed information. Build info.
Also, Jesse, on the contract name, the contract's actually still named my token. Just change the symbol and the name of the token, but
You're
still
right.
named.
So that's where it got it from, is the name of the contract, which is still my token. I should have changed that. Now on chain, you're going to see this and this because that's the symbol and that's the name that the contract has. But in the code, yeah, it's named my token, which is where it gets it from.
Also, when you get a chance, can we mint some to the addresses that were dropped in the chat?
Yeah, let's do that next. So my token .json, that's my token here. This is going to be all of the data about the whole deployment is what we're looking at here. So this is like everything about when you deployed it. Can I collapse here? Let's see here. Does it let me collapse? No. I'm trying to get the ABI because I want to show that on Teloscan you can import the ABI. I believe this would be it at the end. Inputs. This should get us the ABI. If I'm lucky. There we go, ABI, that array. So we copy that. So if you come to Teloscan, you have a few options. Because we know that they're common, we have these ABIs here. So if you wanted to interact with a contract, so here's the concept of verification. It does two things. Verification lets people see your source code so they can trust you. Well, so they can trust the code. Verification says, we know with certainty because we compiled the code ourselves and compared it to what's on chain. We know that this is the source code of this contract that's been deployed. That lets people read the code and build confidence that there's not any backdoors or exploits or anything like that. The other thing that verifying does is it takes that compiled contract, it gets the ABI out, and now we know all the functions. So we can give you a way on Teloscan to interact with the contract. And if other developers maybe want to build an integration to your contract in their front end, they need the ABI as well. They need to know what the functions are that they can call. So here, we already have the option to use the ERC20 ABI. So if it's a contract that's a token, but it hasn't been verified, but you're confident that it's an ERC20 and you just want to, transfer something, we can help you with that. If it's an NFT contract, ERC721, that has not been verified, but you just want to transfer a token, we can help you with that. Safe transfer from, or I think transfer ownership. So the third option is ABI from JSON. So if we paste the ABI that we got, then you can see here all these functions, all the data that I just copied from Remix allows us to see these read functions here and these write functions. So just like we saw in Remix, what's the symbol? Fast, right? What's the total supply? Is it 0 or is it 5? Or is it 5 with 18 zeros? So you can see now we can read it and we can write it. So let's see, who is the first to ask for some tokens? Copy that address for Jacob, and we will mint to Jacob, and we will give you, what did I say? Jacob, you're getting more than 5. You're getting 7. 7 to Jacob. So now we have that, and apologies. Need to sign in. If you don't sign in, you don't get a button. Now we have a button. Oh, this one's not working right now. Maybe because I wasn't logged in. All right, we'll get to that in a second. What I do also want to do is refresh this because voila, now it shows the name, and the name is my token because I think we get it out of the ABI. So we get it from the file name, actually, if you look, the file name. So this code is now verified because I verified it on Remix here with that plugin. It made it to Sourcify. We pull the data from Sourcify every 10 minutes. So you got to give it maybe 10 minutes from the time that you verify with Sourcify before it's going to show up here on Teloscan. But you get the green check mark, and now we have all the data about the contract. Not only do we have the file that we've been looking at, but you can see all the other files, right? The metadata file that's got the name, symbol, decimals. You've got the burnable, the implementation of burning, implementation of it. This is the big one, ERC20. It's got all of the transfer, approve, all of the logic of an ERC20 is all here. A lot more code to look at. And pausable and ownable, the little modifier that checks if you're the owner. You can also transfer the ownership here. There's functions to transfer ownership. There's functions to renounce ownership, which basically means give ownership to the zero address. So you can see everything about this contract. And if you were worried about it or wanted to just take a closer look, you can now see if there's any vulnerabilities, backdoors, etc. The other thing that you get is the read interface and the write interface. They're all now available through the UI here for anybody. Nobody needs to have the ABI because the contract's verified. We have the ABI. It's actually in the output, I believe, right here. So that ABI is all available for anybody that wants to look at this. Now let's see if this will work this time. It may not. And if it doesn't, we'll open a bug and we'll fix it. Gotta copy that address again. All right. So I think the problem was that I logged in after I loaded this page. So as long as you're logged in when you go there, it should be good. It has a pop-up here. I'm confirming that I sent to Jacob 7 of these. I can click. Now it shows the transaction here. I click that. It takes you right to the transaction. Boom, 7 fast. Sent really fast to Jacob. Has a name for the contract now. And you can see Jacob is now the biggest fast whale on the network. That is why you want to verify. And that is one of the many things that Teloscan can offer to users is contract information and the ability to interact with it directly. So, any questions so far? That was a pretty good run of doing stuff. So, anything we can talk about specifically? See if, no.
There was a question on asking if we were able to do this with account names instead of with keys.
Technically, no, you can't do the MetaMask part. The Telos EVM is a smart contract that's actually a smart contract on our native network, so they're all the same network. And the EVM contract does let native accounts, which have a name and then associated public and private keys, it does let you sign and send transactions with your native account technically. But you would be doing all of that through the native wallets. So all of the tools that we've used here that are built for EVM, you need to be using an EVM address. So MetaMask, is not an option for native accounts. So technically the answer is yes, you could send it. You would have to be crafting these transactions yourself using some scripts, and then you'd be sending those transactions yourself through the native wallet. One thing I will mention though is if we look here, if I log out and when I go to log in, technically you can come here and you can log in with a native wallet. The real purpose of that is so that you could come to a token, and you could, if somebody sent a token or an NFT to your native address, so the native account, like my native account is, jesse.tcd. I can generate an address in the EVM for that native account, and somebody could send it a token. The only way to recover that token would be to come here, log in with Anchor, and transfer it over to my MetaMask address, where I can actually use it more properly in the EVM. The reason we don't really encourage it is because it's kind of necessary for some of the deposit and withdraw activities, and it's necessary for some of the interoperability between our native network and our EVM. We're working on some pretty cool stuff with that, where we will be able to bridge tokens back and forth and do some other really cool stuff, all on chain in a single transaction and not using oracles and bridges. But the reason is that the address that's generated for jesse.tcd, I don't have the private key for. And if I ever accidentally use that address on another network besides Telos Testnet or Telos Mainnet, I don't have the keys for that address. So no other network's going to let jesse.tcd transfer that NFT or use anything that's sent to it. So we really discourage people from trying to use, the native account on the EVM unless they really know what they're doing. So let's see, what was next on our agenda there? So we've minted via Remix, verified via Remix. We copied the ABI. We were going to call some other functions. Okay, well that's the next one that's on the list. So I will show you this, which I think I clicked on once already. So I'm running I'll show you right here. So this is on our, if you go to our Telos network GitHub and you look down here, we have this ERC20 EVM. It's named EVM UI template, I believe. We have a lot of them here, right? EVM UI template and EVM UI template examples. So these repositories here are basically a template that will let you get started. It's basically a UI that has MetaMask integrated. It's this UI. So it's got some examples. It's got a login button. So if you're inclined, this is all in Vue using the Quasar component library. If you're familiar with Vue or React, or if you're a front-end developer, this might help, bootstrap and save you some time. So it's got some simple examples for dealing with the ERC20 tokens. So I logged in. Let's confirm here. A01CD is the 01 CD. So this address, I'm logged in, right? My talk, that was another test token, but you can add more tokens. So if I come here and I copy this one here, I should be able to paste it and click plus. Look, fast, boom, and I have 5 of them. Awesome. So somebody else wanted some tokens, right? Copy this address, and I will, so this just gives us an example of how to send tokens. So I'll give you all I got because I can mint more. I'll send more to this address. Again, MetaMask pops up. You can't see it right now. I click confirm. It's transferring. It's done. It's fast. My balances should update pretty quickly. I don't know how often that balance updates, but you can see here that I sent 5 away. I can click here and see it on Teloscan. And then there you go. I have 0. That's refreshed now too. So you can come to this UI and you can see how to send transfers of tokens. You can see how to transfer the Telos. You can see how to integrate MetaMask. This is all public. In fact, this one is a repository, but this one here is a template right here. So you can actually come to this and click use this template. It'll fork it for you and put it on your GitHub. And then you have a starting point. Or you can just look at it for examples on how to do this stuff and get started with building a front end for your token.
Hey, real quick, could you also paste in the contract address of the token to the chat so they can add it to their wallets?
Sure. And that was here, my token. So, let's see, that's now in the chat. That is the contract address of my token. What was the other thing we were thinking about doing? Well, first, let me mint just a couple more, because 5's not enough, right? What's crypto if it's not a big number? All right. That would be right here. So mint to you there. Oh, I'm going to sign in. Got to use Metamask. Going to refresh it because I don't think it works if you weren't logged in when we opened the page. Make some whales here. That one, and then that one, just for fun. All right. So there we go. A few seconds ago, some mints of my token. We can come back now to my token. We can check total supply is much bigger than it was before. And you should be able to see all that stuff now. I think there was one other thing that, well, do we have any other questions here? And do we have time? We got 3 minutes left. So on our agenda was the code to Nathan, I was thinking about doing the code snippet you had here. So this is some code that Nathan cooked up that will add your token to MetaMask. Now you can kind of ignore some of this. I could show us, if I had more time, how to add a token. We could add this code to this template pretty easily, but we'll just use this for now, just to show our balance and how it works. So you would need an image. We'll just keep this image. The symbol would be fast. The decimals is 18. And the token address is this. Well, I guess I need to mint it to myself first. So I need a balance to show, right? That looks good. Refresh. All right, so now I have some, and I will copy that address, make sure that is this address here. All right, so now if I click add token to MetaMask, it's going to make this call to MetaMask to add this token address with this symbol and 18 decimals and that image. What's this image?
I think it's just some gradient.
Oh, we need something better. Fast logo images. Find something good. Speed logo. I like this one. So if I open image in new tab, boom, there's another URL. And we'll go here and we'll paste it. All right. So now, if I click add token to MetaMask, using this code pen that Nathan has, you can see it's going to add that token to this account. Now I can come here and I can look at my tokens, and I can see that I have 0.00123. I didn't smash enough numbers because I didn't even get 18. Looks like I maybe got 16 numbers in there, but I have 0.00123 fast, and we have a logo for it and everything. That's awesome. And I
Can
can
you
send
open
it
it in
now.
the extended view so we can see it as well?
Oh, shucks. Sorry. Yes. Good call. Fast, right? So it did a pop-up, asked me to approve adding fast to MetaMask when I clicked that button. And now it's in MetaMask here. It has the logo that we picked, and I have 0.00123 fast. And I could send them to somebody if I wanted, or I could just keep them myself because they're fast and they're valuable. So, and I think that hits us to the 1 hour mark. Let's see. I think, we had one other thing that we wanted to cover if we had time, but for now, I think we covered everything we wanted to cover as far as Remix, OpenZeppelin Contract Wizard, the concepts around deploying a contract, and I think we saw a few different ways to interact with it. You can interact with it in Remix, in Teloscan, and if you add the token, you can send it through Metamask. I also have a lot of LOL tokens. This is the original Testnet test token, LOL, and a couple others. So any questions at all, or should we call that a wrap? I will say, in this example, we never opened an IDE except for this web-based IDE. So, I was just thinking I didn't have to share anything other than my browser, which is kind of a nice way to do it. Just keep it real simple in the browser. I would say this here is running on my machine, so I'm running this website is running in my IDE. So if you were to start building a front end, you probably wanted to run this in VS Code or some IDE standalone, but otherwise it's pretty simple, nice way to interact with the blockchain and deploy token contracts and get something going on testnet. So if anybody tries this and is successful, let us know. If you hit any hurdles, let us know, ask your questions, or if you have any other questions or you come up with questions, you can come ask questions on the next office hours. And also, if anybody has any topics that you'd like us to cover on the next office hours, please just let us know in Telegram, Discord, whatever. Just let somebody from the team know what things you'd love to see covered on our next edition of office hours.
Yeah, thanks everyone for coming. This was really sweet, and yeah, hopefully we'll have some more ideas from y'all for next time, and yeah, excited just to continue to learn with everybody. So yeah, thanks for coming, and please try it as well and let us know how it goes. We'd love to continue to walk with you through this. So thank you guys.
Thanks everybody.